Hello again. Summer Smasher Student Showcase 2024 is in session. And next on the list is Team Rhoman Aerospace to talk about what they've been up to this summer. These are students that have been with us for 8 weeks, and I can't wait to hear what they've been able to accomplish. Please take it away, Team Rhoman Aerospace.
Okay. Hi, everybody. We are the Rhoman Aerospace Summer Smasher team, and we're very excited to share with you what we've been working on this summer. So, Rhoman Aerospace, what is the problem that is getting worked on here? So, GPS-based navigation for drones is difficult. It's not always available. So, where Rhoman Aerospace comes in is it has a solution to enhance navigation using machine learning and computer vision. So now some of those problems with, maybe there's not great GPS connection, maybe it's not very precise, those problems can be mitigated by these new solutions. That can result in better battery life, better performance in terms of precision and range, as well as a modular system that can then work on many different types of drones. So among the Summer Smasher students, the projects we worked on included deep learning, computer vision, simulation, 3D modeling, framework upgrades, and map reconstruction, all to work towards that goal of improving navigation. And now I'm going to hand it off to Koya, who's going to talk about their project.
I don't hear the audio for Koya. Maybe you might have to do that same thing that the team just before you had to do, which is find out how to do share your audio through the screen share.
All right, 1 second.
There's just like a toggle, but it's like a radio button.
When you reshare, there's a bottom left button that allows you to share audio. I don't know if you can control it while you're currently sharing your screen.
I've seen people do it when they're currently, but don't ask me how. Maybe just stop sharing and then reshare. It's the easier way to do it.
Wait, see if this works now.
No, just stop sharing and reshare. So when you go to share screen, there is a button or something somewhere, like a toggle that says share audio.
Hello, I'm Koya. I'm in charge of the task to make physics system more flexible. The original problem was that the AirSim plugin has some restrictions due to its APIs. For example, when we try to move drones or consider wind, we need to call some APIs. That means we cannot do anything other than what these APIs cover. To solve this, I have created a new module to bypass those APIs when controlling drones. The challenges I faced were that I needed to dive into the huge code base of AirSim and Unreal Engine 5. For the future work, I'm planning to optimize this system to control as many drones as possible. This can be achieved by making GPU-driven physics system, which enables us to control multiple drones in parallel. Thank you.
Great job, Koya. I'm Daniel. My project was to enable AirSim, which is built for Unreal 4, to work in Unreal 5 to take advantage of its greater graphical capabilities. So this involved updating calls to Unreal's physics engine and porting C++11 code to C++20. So the images on the left show multi-rotor drones in an Unreal 5 environment. Now, shown in the video on the right, I also created an expanding world that dynamically loads and unloads duplicates of a 2x2 kilometer chunk of terrain, so drones can fly around near infinitely. And based on which quadrant of a chunk a drone is in, it will load any adjacent ones and unload any too far away. In the future, I hope to optimize the loading process and make loading look visually smoother so you don't see chunks popping in and out. So next, I'm going to pass it off to my teammate Sydney to talk about the work she did.
Thank you, Daniel. Over the past few weeks, I've been involved in creating 3D models using Blender to be imported into our Unreal Engine 5 environment. I've developed a variety of assets, including trees, houses, and cars. After modeling, I assigned materials and animations to these models to bring them to life. For the future, my goal is to continue importing these assets into Unreal Engine and refine my skills in assigning unique IDs to them within the environment. This will enhance the functionality and organization of the world to continue on and create programmatic variations of the models. Throughout this process, I've expanded my knowledge of Blender, discovering its massive capabilities. Additionally, I've started to familiarize myself with Unreal Engine, realizing that I've only just begun to tap into its potential. I'm really excited to continue this and further explore what these powerful tools can do. Now I'm going to pass it off to Apurva in Project Alpha, who focused on machine vision.
Thank you, Sydney. So the project that I worked on focused on developing a machine learning drift corrector to enhance the existing visual inertial odometry system at Rhoman Aerospace. The goal was to map the geolocation estimates to the ground truth GPS data using inputs such as time delays, control commands, and sensory information as features for our machine learning models. I was able to implement feature processing using flight data, including inertial measurement units and other flight descriptors like angular acceleration, altitude, and position. I then implemented machine learning algorithms such as random forest, linear regression, as well as deep learning algorithms like multi-layer perceptron and LSTM for position and orientation correction. TensorBoard callbacks were also utilized to monitor and store the data of our runs. As shown in the graphs on the screen, the green plots represent the VO plus ML trajectory of the LSTM model for position and orientation correction. The next steps involve using NVIDIA SLAM data to fine-tune our models, bringing the estimates closer to the ground truth with the ultimate goal of achieving navigation correction with an error rate below 0.2%. Now I'll hand it over to David, who will share his work done on Project Bravo. Thank you. Thank you, Sydney. So
Thank you, Apurva. So I'm just going to talk about Project Bravo. This kind of splits into two parts. The first is kind of enabling visual odometry through some algorithmic techniques as opposed to higher compute machine learning approaches. This is for a more specific use case on smaller drones with smaller payload capacities. And what I worked on for this was integrating the AirSim simulator into my local machine, which is a MacBook, as opposed to its native Windows development. I also worked on partial attitude and pose estimation for these use cases via standard algorithms like homography, optical flow, and extracting fundamental matrices. You can see an example of that on the bottom left, where we plot the epipolar lines between two images about a couple time steps away to extract the pose from that. And I also composed a couple of data collection and calibration scripts as intermediaries between the Unreal Engine, our data processing pipelines, our visual odometry algorithms, et cetera. And additionally, for Project Alpha specifically, and for like larger payload capacity drones, I also worked on integrating AirSim's simulator and visual environment with NVIDIA's CUDA Visual SLAM. So that involved taking the Jetson Aura Nano on the right there and basically being able to run that high-end state-of-the-art visual SLAM algorithm on it, as well as building a compute adjustable AirSim publishing node in order to get that information at the right timestamps at the right frequency. But yeah, that's it from Project Bravo, and I will now be passing it on to Project Charlie.
Thank you, David. Hi, I'm Rakshit, and I worked on Project Charlie. My project focused on using AI-enhanced navigation via ChatGPT for scene comprehension and caption generation. I integrated the AirSim Midwest World environment and created scripts for various use cases. I developed an API that sends images to OpenAI's API for analysis utilizing GPT to direct drone maneuvers and store relevant data. So the drone captures 6 images from different cameras: left front, left down, and left back and right back. And in the next image, I'm showing only the left front and right front cameras to demonstrate how the OpenAI API helps the drone avoid collisions by analyzing the images and adjusting its path, as here it sees that the drone's path is heading downwards into the tree and then adjusts its path to avoid collisions. In the final image, you can see how GPT identifies objects in the scene recognizing even small items like garden hoses and lawnmowers, and accurately identifying construction vehicles like excavators. Next, I'm going to pass it on to my teammate Advaith and let him talk about his project focusing on geospatial awareness.
Thanks, Rakshit. So our project was basically divided in two parts. One was the pipeline, the data extraction pipeline, and the other one was the map matching algorithm. So in the data extraction pipeline, what I did was, what I had to do was to potentially find, good data sources where I could find 2D and 3D terrain maps, and then to build a pipeline that actually continuously it keeps on extracting data for the locations that we are interested in. And through the course of my project, I did achieve it. And my data sources were the Google Maps API as well as the Google Earth engine, and I used Selenium WebDrivers to actually build the pipeline. The the bottom left image actually shows an example here at USC where we can adjust our view for various heading, tilts, and rotation values and get images that how a drone would see when it is flying above at a certain elevation. Next, I pass it on to my teammate Chanvi to talk about the map matching algorithm.
Thank you, Advait. Over the summer, I've worked on developing a system to estimate the drone's location by comparing its camera feed with preloaded aerial imagery, um, and by applying homography estimation to transform each of the drone images and then stitching them together to create these single composite aligned images. Um, this process helps in matching what the drone sees with the preloaded map. Um, Moving forward, I'll be focusing on fine-tuning these map matching results to ensure that the estimated drone location is highly accurate. I would like to hand it over to Thomas now for him to talk about his project.
Thank you, Chanvi. So for my project titled Project Foxtrot, I had the goal of developing a custom Android plugin to streamline the deployment of mission objectives to Rhoman Nav with ATAK, or Android Tactical Assault Kit, which is a mapping app. And basically the motivation for this is that the UAV can take input in a GPX file format, which can be uploaded directly from ATAK. However, in order to do this, the waypoints in a route in ATAK need to be named following a specific schema, which specifies the desired behavior at a given location. So basically what this plugin does is it allows users to follow some intuitive directions to specify the behavior that they desire, and it automatically creates a route with the proper naming to be uploaded to the UAV. So in order to accomplish this, I analyzed the ATAK code base, used the Android SDK, and wrote code in Java and XML. So now I'm going to be passing it on to Rakshit to discuss kind of our overall experience as interns at Rhoman.
Thank you, Thomas. As you can see here, we chose 4 keywords to describe our summer experience. So the first word we chose was perseverance, because it represents a determination and resilience needed to overcome obstacles and continue pushing on, which is something we all accomplished during this summer. For me personally, navigating through technical difficulties and coding obstacles in the Airsim project was a staple of everyday life. The next word we chose was exploration. Exploration requires a willingness to venture into unknown territories, which fosters a growth-oriented mindset, allowing us to develop new skills. All of us this summer were required to explore new concepts and learn new ideas to aid us in building our final projects. The next word is adaptability. This quality allowed us to thrive in rapidly changing environments where flexibility is crucial. Throughout our time working on our projects, we had to respond effectively to new challenges and changes as they arose. By taking different approaches and modifying our solutions as needed, we were able to develop the best possible solution and the best possible project. The final word is teamwork. Teamwork was essential for our success, as it enabled us to collaborate effectively, leveraging each team member's strengths to achieve our common goals. Through constant communication, support, and collaboration, we were able to combine our diverse skills and perspectives to create a cohesive and successful project. Thank you for listening to our presentation, and in the next slide, you can find our contact information in case you would want to contact us. Thank you.
Did you guys just finish? Sorry, I was in the middle of a conversation with some students because everybody's so excited. Because they all are getting their certificates. I hope you guys weren't waiting long. Let's hear from the founders. Tom, Jonathan.
Awesome. I absolutely have some positive words. Absolutely loved what the team has done this summer. And really just want to thank everyone for coming to all these morning stand-ups, going through so much great documentation around the work. And I'd also love to pass it over to Jonathan, who worked hands-on with the whole team this summer to share some words as well.
Thank you, Tom. I'm really proud of all the work you all have done. Thank you so much you made this very easy. The hardest part I find when it comes to working with different teams, and especially in a remote environment like this, just sort of getting everyone aligned. But your willingness to coordinate together and to look to one another for solutions, that's just not just going to help you succeed here in the program, but just in life. So I'm glad to so much see that you've sort of taken those lessons to heart, and you've just been, do the grit. What is it? Or one of the expression like the sum of our whole parts, we're not greater than the whole. So the fact that everyone's able to come together so effectively, with some structure and some sort of guidance and just run with it, it's just phenomenal to see. So thank you all so much, and I'm looking forward to continue work with you all in the future.
For sure. This stands as another one of these very kind of hardware style or like deeper style tech companies that also works within the challenging area of aerospace. And so I hope you guys got some really great experience understanding what that kind of landscape is for the startup community. And also just, I love Tom. Tom's been, this is something I said in the first round. I've known Tom for a very long time. So a friend of Tom is a friend of mine, and you guys were all probably my friends before you were Tom's friends, but we're all friends here now. I'm glad you were able to help him out. This is Tom's last year with us, and so I'm saying goodbye to many people at the Startup Garage. But yeah, thanks for your time, you guys, and have a great summer.